our next tricks, we're looking at f of x being equal to another hyperbola in the form of 8 divided by x minus 2 plus 3. Write down the equations of the asymptotes of f if you want the marks for number 1. Let's have a look. Well, for now we should know that means x is equal to 2 for a vertical asymptote, and well, y is equal to 3 for number 2. X and y intercepts. For x intercept, y needs to equal 0, so then we'll have 8 over x minus 2 plus 3 equals 0. That simplifies to this. Now we can cross multiply and we shall have minus 3x plus 6 all equal to 8. So negative 3x is just equal to, if we subtract 6 from both sides, end up with 2, thus making x equal to negative 2 over 3 if we divide both sides by 3, of course. Now for y-intercept, we need x to equal 0. So let's do that, and we'll have 8 over, well, what did we say? X is equal to 0. And then add 3, that is of course the y version. Well, that's just negative 4. Negative 4 plus 3 gives us negative 1. Therefore, y is equal to negative 1. Then, predictably, we're being asked to sketch the graph of f. We need to clearly show any intercepts with the axes, and as well as indicating asymptotes. So, let's do this, man. Okay, so there we have a system of axes. Let's get some sort of let's use a gray line and see if that works for asymptotes. Well, we need a vertical one at 2. Sounds good. I think it's a bit too far right. And no, that is not a political statement. And then, yeah, there we go. Let's get our pin back. And a cheerier color, I think. Gray is just gray. So that is of course y being equal to 3, and this is x equal to 2. Well, our x-intercept exists at negative 2 over 3, and our y-intercept should be a bit further down, so that's minus 2 over 3 if we want it marked, and this is negative 1, which does gel because our a value is positive, which means our asymptote, the curves sit there and there. Let's get them sketched in. This one obviously needs to go through those two intercepts and approach the asymptotes. Not the sexiest curve ever, but it'll do. Obviously that quadrant deserves its half of the curve. Well, let's see. We have our asymptotes indicated as well as marked, and then we also have our intercepts done and dusted. Well, that's obviously the x-axis, and that's the y-axis. So if y equal to x plus k is an equation of the line of symmetry of f, calculate the value of k. That shouldn't be too difficult. Let's just sketch this in. That's an axis of symmetry. And why am I doing it with a positive gradient? Well, this is quite literal over here. From theory we know the one with a positive gradient is normally written in the textbooks as such, plus c, and we explicitly know that that is equal to 1. Now, which values do we need to use? Well, the axis of symmetry is always going to go through where the asymptotes intersect each other. So an x value and a y value is always known. We just drag it out of the equation from the appropriate spots right over there. So for this case, now that's going to be the y value. 3 is going to equal, well, the x value we need to use is 2 plus c, subtract 2 from both sides, and we can see that c is equal to 1. Therefore, the equation being required is x plus 1, which tells, if we look at where that cuts, even though this is a very rough diagram.